Other stories we think you should know about today include it's full circle for Australia's biggest gold miner, Newcrest, as it was acquired for $26 billion today by the world's biggest gold miner, Newmont.
A massive steel cable, thicker than a human arm, is pulling 28 tons of gold ore up a hole 1,460 meters deep. At the bottom of this shaft, the world is a different place. The rock is a blistering 60 degrees Celsius, hot enough to cook an egg. This isn't just a mine, it's a $1.8 billion bet against nature. Welcome to the Newmont Tanami Expansion 2. Located 540 kilometers northwest of Alice Springs, this is one of the most remote construction sites on Earth. We are looking at the race to build Australia's deepest mine shaft, reaching for a jackpot 2 kilometers underground. How do you build a skyscraper-sized elevator in a desert where the ground itself wants to crush you? To understand the future, we have to look at the grit of the past. In 1898, explorer Alan Davidson arrived in this red wasteland. For 3 years, he battled the heat, guided by the Walpiri people. They called this place Tanami, their word for rock holes that never ran dry, even during the most brutal droughts. Davidson found gold, but the tyranny of distance was too great. In the early 1900s, there were no roads, no power, and no water. It wasn't until 1986, nearly a century later, that the first gold bar was poured. Initially, it was a daylight operation, open-pit mining. But as the surface gold thinned, the miners realized the motherlode was diving deeper. By 1994, they abandoned the sun and headed underground. Today, under Newmont's leadership, it has become a subterranean titan, aiming to stay productive until at least 2040. The crown jewel of this expansion is the hoisting shaft. Imagine a vertical tube nearly 1.5 kilometers deep. To put that in perspective, you could stack 5 Sydney Harbour bridges inside it and still have room to spare. But you don't just dig a hole this deep, you engineer it. They used a technique called raise boring. First, a pilot hole, tiny by comparison, is drilled from the surface all the way down to the existing tunnels. Then, a massive 5.4-meter wide cutting head is attached to the drill string at the bottom. The machine then pulls that head upward, grinding through solid rock. It's a slow, violent process, but the desert didn't make it easy. The engineers hit poor ground, zones where the rock was fractured and unstable. Then came overbreak, where the walls began to collapse under their own weight. To save the shaft, they had to install 7,947 specialized rock bolts, pinning the Earth's crust back like a giant surgical procedure. Once the hole was bored, it had to be lined with 21,016 cubic meters of concrete. In any city, that's a few dozen trucks. In the Tanami Desert, it's a logistical nightmare. Because the nearest town is hundreds of kilometers away, they had to build a dedicated concrete batching plant on site. The heat was the enemy. If the concrete dried too fast, it would crack and fail. They used specialized high-speed transit mixers and chemical retardants to keep the liquid stone workable. Every inch of that 1.4-kilometer wall had to be perfect. Even a small underbreak, a bump in the wall, would snag the high-speed gold elevator, requiring workers to go back in with grinders and explosives to shave the rock down to the millimeter. But why build a hole instead of a road? Right now, massive haul trucks have to spiral their way to the surface. It's a 3-hour journey, burning thousands of liters of diesel and wearing down tires that cost $30,000 each. The new hoisting shaft replaces that 180-minute climb with a 2.5-minute skip. The machine doing the heavy lifting is the friction winder. This isn't your standard hardware store winch. The drum is 6 meters wide and weighs 40,000 kilograms. It's powered by a 5.3 megawatt motor, strong enough to power a small town. It moves 2 skips. These are massive steel buckets at 16 meters per second. That's nearly 60 kilometers per hour, vertically. But here's the clever bit. It's a balanced system. As one heavy skip of ore comes up, an empty skip goes down, acting as a counterweight. The motor even uses regenerative braking, turning the downward momentum into electricity to be stored in massive battery arrays. It's a masterpiece of industrial efficiency. If the power fails, the miners die. At 2 kilometers down, the ambient rock temperature is 60 degrees Celsius. Without intervention, the air would be unbreathable within minutes. To fight the heat, they've installed a 35-megawatt cooling plant, the equivalent of 40,000 domestic air conditioners. This fridge sits on the surface, chilling the air before it is forced down a massive ventilation network. Below ground, 150 auxiliary fans push that cool air into every corner of the workings. And it's not just the air that's high-tech. The entire mine is blanketed in a private Wi-Fi network. Using the Caterpillar MineStar system, dispatchers on the surface can see the heartbeat of every machine and the location of every worker in real time. If a truck's engine temperature rises by even a few degrees, the computer flags it for repair before a breakdown can block a tunnel. This digital oversight is expected to slash vehicle accidents by 60%. What is all this effort for? Gold. High-grade gold. The Tanami ore body holds between 4 and 8 grams per ton. When the expansion is finished in late 2027, the processing plant at the Granites, 44 kilometers away, will ramp up from 2.6 million to 3.3 million tons of rock per year. This isn't just profit for a corporation. The mine pays $150 million in annual royalties and taxes. It funds schools and healthcare for the Walpiri people. It supports a FIFO village for 1,800 workers who fly in from Perth and Darwin to work 2-week shifts in the red dust. But the desert always demands a price. In February 2026, the project was halted by the tragic death of a worker. It served as a somber reminder that no matter how much smart tech you have, underground mining remains one of the most dangerous jobs on the planet. And pulling wealth from the earth on this scale doesn't come without leaving a footprint. Operating a massive industrial hub in a delicate desert ecosystem presents a significant environmental puzzle. The Tanami operation requires vast amounts of water and a constant stream of high-voltage electricity, resources that are notoriously scarce in the outback. Critics and local observers have raised concerns about the long-term impact on the water table and the carbon intensity of such a massive power draw. In response, Newmont has begun integrating water recycling systems and is exploring large-scale solar arrays to offset the mine's reliance on diesel and gas. For the engineers on site, the next great mega-build isn't just about digging deeper, it's about proving that Australia's most ambitious mine can eventually operate with a lighter footprint on the ancient land that sustains it. As we look toward 2027, the Newmont Tanami expansion stands as a testament to what happens when old-school grit meets new-age engineering. They are literally moving mountains from the inside out. If you enjoyed this deep dive into Australia's subterranean frontier, hit the like button. It helps the channel more than you know. Subscribe to join us for our next mega build. And tell me in the comments, would you work 2 kilometers underground for a share of that gold jackpot? See you in the next one.